Hey, this is just going to be a quick demo of an RC circuit charging and discharging. Um, in the space directly below me, there is like a sensor interface that I'm going to use to make graphs of the voltage on the capacitor. And on the left, you can see a little camera view of the circuit that I have built on the desk in front of me. It's just being powered with a regular battery. It's a D cell, so it's 1.5 volts. And the battery is connected to the circuit, which I've built on this breadboard here. If you've done robotics or any kind of electronics hobby work, you may have seen one of these before. It's just a way of quickly making and rearranging circuits. You can plug these little wires directly into the holes without needing solder or clips or anything like that. So the circuit I built has two button switches. This button here, when I press that, it's for charging the capacitor. And then there's another button here, which I can press down to discharge it. And obviously there's a big capacitor in the middle. There's also a resistor down here. This resistor says brown, black, red, which would be 1, 0, and 2 zeros, or 1,000 ohms. And the capacitor along the barrel says 1,000 micro. Doesn't want to focus. It says 1,000 micro. So that means that the time constant, R times C, would be 1,000 times 1,000 micro, which would be 1,000,000 micro, which would be 1. So the time constant should be around 1 second. These two spare alligator clips go to my voltage sensor. So I'm just going to put one on that leg of the cap and this on the other leg of the cap. Maybe I'll bring it around here just to make sure they don't touch each other by accident. So let's record some data real quick. I'm going to hit start on the interface, and initially it's just going to show 0 because there's nothing going on. Capacitor is empty. But when I hit the charging button, look at that. Voltage is rising up. It was going pretty fast at first. Now it's leveled off, and it stopped at around 1.5 volts because that's the voltage of the battery. Let me stretch this out a little so you can see the curvature more nicely. It's easy to begin, and so you get rapid changes, but as the capacitor fills up, it gets harder and harder to put more charge in it, and so it slows down, and then you reach that maximum level. Hide that. I'm going to start again. Should still be pretty high up there. It's dropped a little bit. And I'm going to hit the discharge button. So it's now on its way down to 0, but you can see that again, it happened pretty rapidly at the beginning. It got slower and slower as it went. And that's because when you are emptying the capacitor, the charge wants to get away from the capacitor most at the beginning, because there's already a lot of charge in there. And all of the charged particles, they repel from each other. So when you first begin to release the charge, it's going to be pretty vigorous. And when there's only a little bit of charge left, it will be, more sedate. So I'm going to run it again, put both the charge and the discharge on the same graph. So I'm going to go up. And again, it maxes out in this circuit at around 1.5 to 1.6. Bring it back down. And that time constant, which I calculated to be around 1 second, is not the time that it takes to get up to the top. Even if we think about starting here, coordinates for that point are 2.6 seconds and 0-ish volts. I'd say it didn't really get up to its maximum value until somewhere around here, which is 7.5 seconds. So it took a lot more than just 1 second to go from its starting point to its final point. And that's because the time constant represents the amount of time that it takes to go like roughly 63% of the total distance that it's gonna go. And then in the next time constant, it goes 63% of what's left. And then in the third one, it goes 63% of what's left again. And so the steps get smaller and smaller. And that's why it sort of levels off calmly. Now the other thing I want to do is swap out the capacitor. So I'm going to disconnect this one. And again, this was a 1000 microfarad. And I'm going to put in a 100 microfarad in the same spot. So it's 1/10 as much. Time constant should be 1/10 of what it used to be, which basically means it should look a lot faster. So let's hide that run. Start. Looks like it's I get that down to 0. Okay. I'm going to start, and it's probably going to go pretty darn fast. It's already at its maximum, and it's down to the minimum. One thing to note, do one more run where I just charge it. I'm going to let go of the button now. And you can see that the voltage is dropping. When the button is not pressed, according to the design of the circuit, the voltage of the capacitor should be fixed because there's nowhere for the charge to go. So what I think is happening there, sometimes the capacitors are just kind of like junky and they have a little bit of leakage, and so the voltage drops over time anyway. But frankly, I think it's because I have this voltage sensor connected. Because remember, to connect a voltmeter, I need to clip these two things on, and these lead somewhere, and so they are connected to each other on the other end. Voltmeters usually have a pretty big resistance, so that you don't get very much current through them, but I think that's what's happening here. I think that a little bit of current is leaving the capacitor through my sensor, and that's allowing it to discharge even when I don't want it to. That's just my guess, though. But anyway, that's what a real circuit looks like, and that's what the data from it look like too.